Hello all, and welcome to Matrix Basics, video number 1. The objectives in this video are to define a matrix, to give the dimensions of a matrix, to take a matrix times a scalar, to add and subtract two matrices, and to solve a simple matrix equation. So let's get to it. Many students, when they hear the word matrix, think of the Keanu Reeves movie. And while that's a good movie, it really has nothing to do with matrix as we will study them in this video. I like to define a matrix as a rectangular arrangement of numbers in rows and columns, or even more simply, numbers in rows and columns. By the way, as you can see written here, the plural of matrix is matrices. In the math world, whenever you see brackets around rows and columns of numbers, that would indicate a matrix. You can see here in this one on the left, the brackets indicate that's a matrix. These brackets indicate that's a matrix, so on and so forth. As for the dimensions of a matrix, dimensions are given as the number of rows by the number of columns. The number of rows by the number of columns. Rows go across, columns go down. And so in our first example here on the left, you can see this has 1, 2 rows, and it has 1, 2 columns. Therefore, it's a 2 by 2 matrix. If one wishes to, you can write the word by, by, but it's more commonly done with an X, 2 by 2. In the second matrix here, we have 1, 2, 3 rows, 1, 2 columns. Therefore, it's a 3 by 2 matrix. In the third example, we have 1 row and 1, 2, 3 columns, making it a 1 by 3 matrix. And a rather silly example here on the right. Obviously, this has 1 row, 1 column, making it a 1 by 1 matrix. So just remember, dimensions are number of rows by number of columns. Next, a little more vocab for you. In a matrix, each item within the matrix is called an element. Each item in a matrix is called an element. When you have a number out in front of a matrix, as in this first example, that's called a scalar. So in this example, we're taking a scalar of 3 times this matrix. And to do that, it would be very much common sense. You would take the scalar times each individual element. So if we take 3 times 3, that would be 9. 3 times 0, 3 times negative 1, 3 times 4, 3 times 2, and 3 times 1. That's what you get when you take that original matrix times a scalar of 3. Very much common sense. Next, let's look at how you might add two matrices. Adding is also very much common sense. To add two matrices, you would simply add corresponding elements. In other words, the top left number in the first one would be added to the top left number in the second one, so on and so forth. So 4 plus 3, 2 plus 0, -1 plus 1, 6 plus 1. To add two matrices, add corresponding elements. Very much common sense. It would probably logically follow that to subtract two matrices, you would do the exact same thing. Subtract corresponding elements. So in this example, we would take 3, subtract -2. -1, subtract -1. 4, subtract 0. And 2, subtract 3. Subtracting two matrices, very much common sense. Let's move on. Here is a basic matrix equation. We have a 2 by 2 matrix equal to a 2 by 2 matrix. I think it would logically follow that each of the corresponding elements would be equal. 3x plus 1 would have to equal 10. Let's put that in an equation. That will allow us to find x. Subtract 1 from both sides, divide by 3. Of course, 2 is equal to 2. That doesn't help us solve this matrix equation, but it is a fact. 16 would be equal to 16. And the next piece that we're really interested in, 3y minus 1 would have to equal 14. That gives us our equation to find y. Add 1 to both sides, divide by 3. So when it asks us to solve this equation, no different than solving a regular equation, you're trying to find the values of x and y that make it work. That's it for video number 1. Hope you've enjoyed the information presented here. Thanks for watching.